Let's start with basic trig definition. So basic trig definition. So we have the first trig definition, which is sine of theta, which is equals to opposite over hypotenuse. Don't worry, I'll give you a way to remember these things. And the definition of cos theta, which is equals to adjacent over hypotenuse. And we also have the definition of tan, which is tan theta is equals to opposite over adjacent. So there is a way where we can remember all of these definitions, where most of us, actually me, I use so, ka, toa. So, ka, toa. When I see so, I know the sine, the definition of sine is opposite over hypotenuse. And when I see cos, I know the definition is adjacent over hypotenuse. When I see tan, I know that the definition is opposite over adjacent. So let's look at this in a diagram. So let's take this is our A, this is our B, and this is our C. And we have our 90 degrees here. Remember, there's to have a 90 degrees for us to do all of these definitions. And we have our theta there. So how do we apply all of these definitions? First thing you need to know is that the adjacent side is always from the angle theta, or whatever angle you'll be looking for, to the 90 degrees. So we get our adjacent. So adjacent, our adjacent side will be adjacent side will be from theta to 90 degrees. So this will be our adjacent side, from theta to 90 degrees. So how do we find our hypotenuse? So our 90 degree corner, this corner, will be facing our hypotenuse. So this is our hypotenuse. It's always being faced by the 90 degree corner right there. So it will be facing our hypotenuse. So the leftover side will be the opposite. The leftover side will be the opposite. So our hypotenuse is faced by our 90 degrees, there, and the remaining side, it's our opposite. The side that remains will be our opposite. So this side that remains will be our opposite. So let's look at how can we apply this information. Let's go and check how can we apply this information. Example 1. Let's take your given triangle. Let's say our triangle is triangle A, B, and C, where we have our 90 degrees right there and our theta right here. Then they say, they tell us that we must find sine theta, cos theta, and tan theta. So how do we find our tan theta? We know our definition. How to find all our definitions? We know how to identify our definitions. We said from theta to 90 degrees, from theta straight to 90 degrees. That's where we have our adjacent. So our adjacent side is always from theta to our 90 degrees. And our 90 degrees, we said it faces the hypotenuse. So this is the hypotenuse, and we said the remaining side will be our opposite. The remaining side will definitely be our opposite. So we know the definition of sine using SOHCAHTOA. So we're going to write it up there and say SOHCAHTOA. TOA right there. So we know the definition of sine. Our definition of sine is opposite over hypotenuse. So every time we see sine theta, our sine theta will be opposite over our hypotenuse. So what is our opposite? So we go and see where our opposite lies. So we see our opposite, it lies between B and C. So our opposite is B, C, and what is our hypotenuse? So our hypotenuse, we discover that it is, because we already identified it, it is our AB. So we're going to write our AB. Then just like that, we are done. What about our cos theta? What about our cos theta? Our cos theta, by SOHCAHTOA, we know that cos is equals to adjacent over hypotenuse. So we have our adjacent there and our hypotenuse. So we're going to say cos is equals to adjacent over hypotenuse. Hypotenuse there. So we're going to go to our adjacent. What's our adjacent? From A to C, we have discovered that it is our adjacent. So from A, C, it is our adjacent. Our hypotenuse, what is our hypotenuse? Then our hypotenuse, we have found that it is from our A to B. So we're going to write from A to B. And just like that, we have found our answer. Now the last one, our tan theta, we go back to our SOHCAHTOA. Tan, our tan is equals to opposite over adjacent. So our tan is equals to opposite over adjacent, our adjacent side, which is equals to, what's our opposite? Our opposite is BC. So we're going to write our opposite right there. Our opposite is BC over our adjacent. Our adjacent is AC right there. So we're going to write it AC, and just like that, we have found our answers. Let's just take a last example so we can read these things. So let's take, we are given a diagram like this, and let's take, here we have our R, here is our R, here we have our S, here we have our Q, and then we have our P. Let's take that, our P right there. Then they say write down two ratio for cos R. We know that, okay, R, this is R, this is our angle R right there. So we're gonna look for 2 ratio for cos R. So which triangle can you use? Because as you look at this, as you look at this diagram, you notice there are multiple triangles that are in there. So which triangles can we use? Like when we're looking at our triangle like this, we notice that, okay, we have this large triangle right here, large triangle right here, large one right there, which has a 90 degrees right here, 90 degrees right there. So from our angle R, straight to the 90 degree, that means we have our adjacent. Don't forget that, it's very important. And we said the 90 degrees, it's always facing the hypotenuse. So this is the hypotenuse. And the remaining side, we said it will be our opposite. So for accuracy, let's mention which triangle we're using. Let's say in triangle RPQ. What's happening in triangle RPQ? The cos of R, what's the cos of R? The cos of R, we know through our definition, through SOHCAHTOA, that our R will be adjacent over hypotenuse. So our adjacent, we have located our adjacent already. We know that our adjacent is RP. See, our adjacent is RP, so we're going to write RP divide by our hypotenuse. So our hypotenuse here is our RQ, so we're going to write over RQ like that. And just like that, we have found our answer. But notice they told us that we must identify two ratios, not just only one. So we must also identify another ratio. Let me just erase this. Let me just erase this. Our former things. Let me just erase all of that. So we're still dealing with angle R right there. So how else can we find our opposite and our hypotenuse? Because we must find two ratios. So notice that we have another triangle, which is triangle R there, P, S, and back to our R. We have another triangle just like that. And notice if here it's 90 degrees, that means also here it's 90 degrees. Because the straight line must add up to 180. So 90 plus 90 must give us 180. So we start identifying our sides again from R to 90 degrees. From R to 90 degrees, that's where we have our adjacent. Don't forget, it's very important. And we said our 90 degrees corner it faces our hypotenuse. Our hypotenuse like that. Our hypotenuse like that. And the remaining side will be our opposite. So there you have it. So in which triangle? Let's say in the triangle that we're going to be using in triangle R, P, S. What's happening in triangle R, P, S? Our cos R will be equals to, remember, it's adjacent over hypotenuse. That's the definition of cos, adjacent over hypotenuse. So what's our adjacent there? So we're going to look for our adjacent. Our adjacent, we discovered that it was RS. So RS is our adjacent. What about our hypotenuse? We discovered that it is RP. So over RP. And just like that, we have found all the sides that we were asked to find. And this will be the end of this video. Make sure you like, make sure you comment, and make sure you subscribe, and see you in the next one.